This is the Lake Luzern paddle steamer Stadt Luzern. Unfortunately, these are the best external views that I have of it. The Stadt Luzern has a 3-cylinder Uniflow engine with 1177 kilowatts, built in 1929 by Gebrüder Sulzer in Winterthur. This engine is quite different from the steam engines found on all other Swiss paddle steamers, which are 2-cylinder compound engines. If you are a bit confused by terms like Uniflow or compound, I'm going to explain these in the next minutes, with a comparison between the Stadt Luzern and the other Swiss paddle steamer engines, including a quick look at what a compound engine is and a more detailed explanation what Uniflow means. These will be done with the voiceover that you can hear right now, which is somewhat unusual on my channel as I prefer to explain things in captions in order to keep the original audio in. After a few minutes I will change over to this usual style of captioned explanations about the individual engine parts. If you are bored by my thermodynamic lectures, you can skip there to this time. And if I made this video in my usual style with captioned explanations, these would result in huge essays blocking the entire screen, hence I chose to voice over parts of the video. The steam engine on the Stadt Luzern also happens to be the most over-engineered machine that I've ever seen, but more on that later. There are reasons as to why it is so complicated, and originally I included these stories in the video, but then cut them out in order to keep the video from getting excessively long. If you're interested, check out my pinned comment below. On the note of over-engineering would I like to point out that I already made a video showing the engine on the Lake Zürich paddle steamer Stadt Zürich. It is linked in the description. If you just like to see a Swiss paddle steamer engine, I recommend to watch that video instead, as this video here presupposes some basic knowledge about steam engines and will get a little complicated. I mean, you just saw the engine room of the Stadt Zürich, now here's the engine room of the Stadt Luzern for comparison. All these yellowish brown pipes are oil, either lubrication or one of the 3 hydraulic systems. By the way, I didn't show much of the Stadt Luzern yet, because I didn't want to spoil this "oh dear" moment of seeing all the pipes. At this point, I also like to thank the Schifffahrtsgesellschaft Vierwaldstätter See and the ship's crew for allowing me to make this video. Usually, passengers can't visit the engine room, just like on any other Swiss steamship. Before we continue, do I just leave this clip in for a little longer, so you can get an all-around look at the engine room. Now, if you haven't seen the Stadt Zürich video yet, I will use my footage there as example for the other Swiss paddle steamer engines, and to compare the engine of the Stadt Luzern to these. The key difference is that the Stadt Luzern has that 3-cylinder Uniflow engine, the other ships have 2-cylinder compound engines. Compound means that the 2 cylinders have different diameters, because the steam first partially expands in the small high-pressure cylinder, before expanding completely in the large low-pressure cylinder. To put it shortly, compounding increases efficiency by reducing the temperature gradient in each cylinder. I don't want to get into too much detail on compounding, because I'm working on a similar video where I explain it on the example of a stationary tandem compound engine that drives a generator in the old Gasworks in Stieren, near Zürich. Plus, this video already is long enough as it is, and I don't want to make it even longer with semi-related infos. Anyway, on the Stadt Luzern, the 3 cylinders all have the same diameter, because the steam expands completely from boiler pressure all the way to condenser vacuum in each cylinder. This is possible because of the Uniflow principle, but before I explain that, I want to get it over with the differences in order to keep the video structured. When looking at the engines as passengers would see them on deck, probably the most obvious difference is that the engine of the Stadt Luzern is placed under plexiglass covers. It has a forced lubrication system similar to an internal combustion engine, which causes oil to spray from the bearings. By the way, can we thank Queen Elizabeth II for these covers. Originally they were made of metal, but when the Queen travelled on the Stadt Luzern in 1980, the cover of the central crank was replaced by plexiglass to show the engine. Because she liked it so much. The covers on the other 2 cranks were soon replaced by plexiglass too. Because of the forced lubrication system does the Stadt Luzern have none of the oiler caps that can be found on many other steam engines, not only on Swiss paddle steamers. Another difference that one might notice is that the Stadt Luzern has no eccentrics or other valve gear visible. Reason is that the Stadt Luzern uses hydraulic oil to open the steam valves. This actually is what makes it so complicated. The Uniflow principle itself is fairly simple. Regarding the comparison to other Swiss ships, is the Lake Geneva paddle steamer Rhone a bit of an exception, as it has a very similar lubrication and hydraulic system. While being a bit crude, this animation does a very good job at explaining what a Uniflow engine is. Steam is admitted by poppet valves at both ends of the cylinder and exhausted in the middle through ports that are opened by the piston sliding over them, comparable to how a two-stroke internal combustion engine works. In a conventional steam engine, steam is admitted and exhausted at the ends of the cylinder, often even through the same channels. In this animation, fresh expanding steam is yellow, exhaust steam is red. As you may know, steam cools down as it expands. This means that the yellow fresh steam is hotter than the red exhaust steam. Hence the cylinder is heated every time when yellow steam is admitted and cooled every time when red steam is exhausted. This heating of the cylinder takes up energy that could otherwise have performed work in the cylinder. Now, in a Uniflow engine, the hot steam admission and cold exhaust are physically separated, which means that the two ends of the cylinder with the admission valves are the hottest part, and the cylinder gradually gets colder towards the exhaust in the middle. This follows the temperature of the steam, which cools down as it expands. As the temperature of the cylinder matches the temperature of the steam, much less energy is wasted on heating the cylinder. This allows a larger expansion ratio than in a conventional steam engine, hence the engine on the Stadt Luzern isn't compounded. Every cylinder can expand the steam from the full 12 bar boiler pressure to below atmospheric pressure, at which the steam is exhausted into the condensers. This all was a bit theoretical, so let's take a look at what this looks like on the Stadt Luzern. Steam is channeled to the engine with this manifold, which distributes the steam to the 6 admission valves, one for each cylinder at the top dead center end and another one for each cylinder at the bottom dead center end. The steam then expands all the way to condenser vacuum in the blue part of the cylinders, before being exhausted into the condensers in the grey cylinder centerpiece. The centerpiece is one large part of cast steel, which connects all the cylinder to the two condensers, one on the port side and one on the starboard side. As hinted, the purpose of a condenser is to create a vacuum below atmospheric pressure. A steam engine that exhausts to the air, like a steam locomotive, can expand the steam to atmospheric pressure. An engine with a condenser can expand to a vacuum below atmospheric pressure. This increases the expansion ratio and by extent temperature ratio that can be used in the cylinders, increasing efficiency. Cooling water is injected into the condenser, where it cools the exhaust steam to condense it back to water, thus reducing the volume by the factor 1700. This alone can't maintain a continuous vacuum. The resulting condensate water and any residual steam left must be pumped out of the condenser constantly. The other Swiss paddle steamers do this with a pump, which is driven by the crankshaft. This design builds up a vacuum as soon as the engine runs, but while the engine is stopped, the vacuum is lost as the pump doesn't pump water and steam out of the condenser. If we look at the Uniflow animation again, we can see that while steam is expanding at one side of the piston, the other side is being compressed. The lower the pressure in there, the less work is wasted on compression. The condenser vacuum must be maintained at all times, as exhausting at atmospheric pressure would mean that the steam engine then compresses beyond atmospheric pressure and wastes a lot of work in doing so. Not only that, but the engine of the Stadt Luzern is so delicately balanced that it couldn't even start properly if the condenser vacuum was lost while the engine is stopped. Maintaining the condenser vacuum while stopped requires an unusual condenser design. And explaining that is where the voiceover ends and my usual captioned explanations start. Lastly, I just want to point out that I had a bit of an audio equipment problem when recording, so please don't wonder if the sound quality varies throughout the video. I also tuned down the volume of the engine clips until now to help understanding the voiceover. From now on, everything will be as loud as if you were in the engine room, so headphone users be warned. Anyway, I'll shut up now.